Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. All right, so our lecture will be start at 2:30. So we have another 1 minute. Okay, can you see my slide?
Can.
All right. Okay, right. So let's start our lecture for today. All right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. All right, so today we go for the new topics. Okay, new topic for AI. There is the artificial neural networks. Okay, so for today, we focus more on the fundamental lah. Fundamental, what is the artificial neural networks? Okay, the applications. Okay, the advantages of neural networks and so on lah. More on theoretical. So today I try to finish on the theoretical lah, related to artificial neural network. Right, so that I mentioned to you. So on our class, we focus only two techniques on AI. First is the fuzzy logics. So, and then another one is the neural network lah. So neural network in Malay is the rangkaian neural. Okay, rangkaian neural buatan lah is the artificial neural networks. Alright. Okay, can you hear my voice? Okay, clear my voice?
Can.
Alright.
Can.
Okay, so that mentioned to you, today is just a theoretical related to related to artificial neural networks. Okay, so next week we will start on the simple neural network lah, on the application on neural networks. Okay, on the technique inside the neural network lah. Okay, right. So first we have to know what is the artificial neural network lah. Okay, how it come how the neural network comes. Okay, actually the neural network is describe the terms computer model assumption from the biological brain lah. That means okay, the neural so this name come from the neuron on the biological brain lah. Okay, they imitate the neuron in the biological brain to do artificial neural network lah. Okay, that is we call the definition on artificial neural network lah. Okay, actually the definition of artificial neural network is the describe the computer model assumption of the biological brain. Okay, that's the definition on neural network lah. Alright, so for today we have the first is the course outline. Alright, and then we explain about the overall course content for neural networks, and then the objective. Okay, so and then we have some overview. Okay, of the neural networks. Okay, the definition of neural networks. Okay, ANNs, the applications. Okay, the models, learnings in neural networks, and also the paradigm and classification lah. All right, and then also using the neural network for problem solving lah. Okay, that is the content for today class. Right, so this is a course outline. All right, so this course on the artificial neural network offer insight to the student to understand what they are. Okay, what is the artificial neural networks? Okay, you can see this one. The neural network is modeled after biological brain. That means it's come from this one. Okay, it's come from the biological brain. Sorry. Okay, it's come from the biological brain. Right, so artificial neural networks or sometimes we call the parallel distributed processor, or sometimes we call the cognitionist model. Okay, there is something known, okay, have been subjected to of study and research since early 1940s lah. I think the neural network is not new lah. Okay, on our research is the start on early 40 something lah. That's why we have before this maybe neural network known as the cognitionist model, or sometimes called as the parallel distributed processor. So now they change to artificial neural network lah. Alright, because of the faster and better computer software and hardware, so the neural network become more important in many applications lah. Okay, from business to medical application and also to engineering problem lah. Okay, that's why we have a lot of neural network in our system. We use the application lah, many application. Okay, we use for AI technique, for example, like business, we can predict the stock and so on lah. Okay, also we can use this one for medicals, okay, to predict the abnormality of the heart, okay, and also a lot of engineering problem lah. Okay, we can solve using the neural networks. Okay, and then there is a score of neural network paradigm which has been proposed. Okay, and then this course will be discussed the details several of this paradigm. Okay, for this actually on the neural network we have a lot of technique. Not like similar like fuzzy. Fuzzy we just have a component. Fuzzy is only one technique, but inside the fuzzy logic we have 4 main component. Alright, but for neural network we have a lot of techniques cover on neural network lah. But for our class we just focus only simple neural networks and then the backpropagation lah. Alright, so actually if you can you can search on the MATLAB, so we have I think more than 10 techniques. Okay, more than 10 techniques lah will be covered on the MATLAB, but for our class we just focus only simple neural networks and also the backpropagation lah, the backpropagation. Okay, so this course will consider the general aspect of neural networks and also their application in the real world. Alright, so this is course outline, and then okay, so this is objective for our topic for neural networks. Okay, first to understand the broad concept of the artificial neural network. So what is the neural networks? Okay, the definition of neural networks, how it come, how the neural network come. Okay, and then to know the possible application of the artificial neural networks. Okay, to relate biological neural networks to ANN. Right, actually that I mentioned to you. So the neural networks, artificial neural network is come from biological neural networks. Okay. And then to understand the capabilities and limitation of neural network, okay, that means I will explain after this. So we have the advantages and disadvantages of the neural network lah. All right, and then to understand the underlying concept of several neural network paradigm, and last but not least is to be familiar with at least one ANN software for the development of neural network applications. So this one similar like fuzzy logic, so we will use the MATLAB lah. MATLAB to run the neural network lah. Okay, we use the MATLAB toolbox. Okay, on the MATLAB we use the neural network toolbox to run the application lah. Okay, to apply the neural network in our system. Okay, we use the MATLAB lah. Okay, at least you're familiar with one software lah for neural network. Similar like fuzzy, so we use the MATLAB. Okay, so this is some question lah. The first question will be asked. Okay, so first is what is the artificial neural network lah? This is definition lah. Alright, so what AN can do? Okay, and how many types of neural network technique are there? So that mentioned to you. So in neural network we have a lot of techniques. Okay, I will show maybe later on, maybe next week on so on. Okay, on the MATLAB we have I think around more than 10. Okay, more than 10 technique lah. But we will be covered on our class maybe 2 techniques, okay, on the perceptron and then the backpropagation, okay, on the MATLABs. And then we can be applied to, okay. So that I mentioned to you, a lot of techniques, a lot of system we can apply the neural network lah, okay. And then how to use or design the neural network to solve the problem lah, okay. This one will be covered, okay, we will cover on our class lah, okay. From definition, okay, so how many types of neural network technique. Okay, so for our syllabus, we just cover for simple neural network. On the simple neural network, we have technique, for example, like McCullough and Pitts. We have the Herbst. Okay, we have the Medellin. We have the Fukushima, and last one we have the back propagation. Okay, so that is the on the simple technique lah, neural network techniques. Okay, and then where can be neural network can be applied to, and then last is the how to use, okay, or how to design the neural network. So this one will be covered on the later on on the class. So I will show you similar like fuzzy logic. So how to design the neural networks, okay, how to apply the neural network in our system. Okay, okay, so this is some background that you need okay, you need to understand. Okay, actually so you have to some background on the mathematical theory lah. Actually that I mentioned to you, we have a lot of technique in neural networks, okay, that involve of many mathematical theory lah. For example, we have the chain rule, differential equation, partial derivative. But I mentioned to you before this, we just use the simple neural network. That means only the simple mathematical, okay, theory we just apply. So maybe only the multiply, okay, multiply only. But actually, the lot of technique they also use the mathematical theory. For example, like chain rules, okay, differential equation, okay, partial derivative, and so on. Okay, and also you need to understand the discrete time equations, okay, sampling intervals, okay, and then also the programming language. So no need nowadays we just use the MATLABs. So no need to understand the language to develop the neural network algorithm lah. Right, so we just use the toolbox. Okay, on the MATLAB we have the neural network toolbox. We just use the toolbox lah. No need to do a algorithm, okay, or programming for the neural networks. Okay, and then some particular neural network algorithm lah. Okay, so we will cover for our class will be simple neural network lah. Okay, simple neural network and also the backpropagation. Okay, so this is an overview of artificial neural networks. Okay, so that I mentioned to you. So this is definition there. Okay, so artificial neural networks, or ANN, is a term used to describe a computer model assumption of the biological brain. Okay, that means this neural network is come from the biological brain actually from the neuron. Okay, neuron inside the biological brain. For example, I will show later on the slide the example of the biological brain. So actually just imitate from the neuron. Okay, so we have the one neuron here. Okay, you can see this one. Okay, this, for example, this we call the processing unit. This we call the processing unit here. So you can see this one. It consists of set of interconnected simple processing unit. This one neuron, or sometimes we call the node, which combine to the output a signal to solve the certain problem based on the input signal we receive. For example, we have this one. Okay, we have this one, and then this is output. Okay, for example, this one we call the x1 for input 1, this one input 2, x2, and this one input 3 lah. Okay, for example, the output will be y lah. We can put y. This one, the output for our processing unit is we call it as s lah. Okay, s, for example. Okay, you can see this one. The interconnected simple processing unit have adjustable gains that are slowly adjusted through the iteration followed by input-output pattern given to the neural network. So on the inputs, okay, we have the adjustable gain lah. So for example, we have weight 1. Okay, this one we have weight 2, and also we have this one we have the weight 3. Okay, this one this weight will be adapt. Okay, will be adapt. Okay, slowly. Okay, depends on the iteration lah. Depends on the iteration. Okay, depends on the input-output pattern lah. Okay, that means this weight. Okay, weight number 1, weight number 2, weight number 3 will be adapts. Okay, that means will be adjust for every iteration lah. For every iteration. Okay, for example, we have 8 iteration. That means the first iteration. Okay, second iteration. This weight will be adjust lah. Will be adapts. Okay, we call the adapt. Okay. Okay, this one, this is only one, we call the only one neuron. Okay, one neuron lah. Okay, or sometimes we call the nodes. Okay, so this is only one, but on the neural network we call the network here, that means we have more than one neuron. Okay, more than one neuron, right? That means this is one neural, all right? Because of the term is the neural network. That means we have the neuron. Okay, the network of the neural. So that means we have more than one neuron. Okay. So this is that I mentioned to you. So other name of the neural networks. Okay, I think this is all version of the neural network. So nowadays they use the terms of neural network. So if you are refer to the previous book, for example, maybe 1950 something, maybe some of the book refer to the cognitionist model, or some of the book refer as the parallel distributed processor. Okay, that is the term that used for describe the neural network. So nowadays mostly we use the neural network lah. Okay, neural network, or sometimes we can call as the artificial neural networks. Okay, neural network or artificial neural networks. So you can see this one, right? So this is one neuron. Okay, one neuron. Okay, this is another one neuron. You can call as the neuron 2, neuron 3. Okay, so for example, this is input, and then this is output, and also we have the hidden. This one we call the hidden layer. Okay, for example, this one we can call as the input layer. This in the middle we can call as the hidden layer. Okay, and this one is the output layer. Okay, it can be more than one inputs. Okay, for example, we have 10. Also for output we can more than one or only one. Okay, for example, maybe to detect the abnormality of the heart. Okay, of the heart. So example, before this they have 36 inputs. Okay, 36. That means x1, okay, x2 until x36. Okay, the output only one. Okay, the output only one. There is the normal or abnormal. All right, for example, this some example they use the neural network to detect the abnormality of the heart. All right, so based on okay. Okay, based on 36 inputs. All right, so this is have been developed. The neural network has been developed as the generalization of the mathematical model of human connection of the neurobiology based on the assumption. Okay, the first assumption, you can see this one. So the first assumption, information processing occur at many simple element called neuron. Okay, this one, I mentioned to draw this one. Okay, this one we call the neuron, or sometimes we call the nodes. Okay, sometimes we call okay, neuron. Sometimes we call the neuron, sometimes we call node, or sometimes we call the processing element, sometimes we call the unit. Alright, so signal pass over the connection link. So every signal will be connect to the neuron. So this is input. Okay, we declare as the input 1, input 2, input 3, for example, and so on. And then this declares the Y output. This output, maybe this one we have the submission of processing unit. Okay, so you can see this one. Each connection link have the associated weights. Okay, that means I mentioned to you. So every input we have the weight. So we can declare as the weight 1, weight 2, weight 3. Okay. Which typical neural networks multiply the signal transmitted. So that's why, okay, for example, to calculate the S, okay, here on the neuron, so will be x1 multiplied by W1 plus x2 multiplied by W2 plus x3 multiplied by W3 and so on. Okay, Sn multiplied by Wn. Okay, that is for example. For example, if we have n's input, okay, that means every signal we have the weights. Okay, we have the weight. Right, so each neuron apply an activation function, usually nonlinear. So in this one, this side we have the activation function. Alright, so usually we use the nonlinear to net input to determine the output signal lah. Okay, for example, normally we have a threshold. We call a threshold. Okay, this one threshold. Alright, for example, there's threshold. So for example, our threshold like this. Okay, 2. Okay, this is 2. Okay, this is 1. Okay, the input. Okay, 1, 0. Alright, so for example, if S more than 2, okay, for example, after we multiply, okay, S1 multiplied by W2 plus X2 multiplied by W2, X3 multiplied by W3, and so on, okay, the answer is more than 2 or equal than 2, so automatically our output will be 1, okay, Y equals to 1, okay, because of this one, okay, so if S, okay, this S is greater or equal with 2, that means our output will be 1. Yeah, our output will be 1 here lah. So if, for example, if S less than 2, for example, like S equals to 1, so automatically 1 here. So automatically we know output is equals to 0. Right? There is some information that you have to know. Right? So a learning rules exists to adapt the weight to solve the particular task lah, or engineering business, or sometimes engineering business and so on. Okay, so to adapt this one, to adapt the weights and the bias, okay, so we have we call the learning rules. So every technique, they have the different learning rule lah, okay, they have the different learning rules. So after this we can go one by one technique lah, maybe on the next week. Okay, so this is some generalization of the mathematical model of the human cognition or neural network. Okay. All right. So this is the study of neural model encompass many disciplines. Okay, such as neuroscience, psychology, philosophy, computer science, mathematical, and so on, electrical and electronics. Okay. All right. So this is I mentioned to you. Okay. This is our from our biological brain. So they study this one. From this one, okay, the biological brains. Okay, they put only one nucleus, okay, or one neuron. Okay, this is we call a one neural. Okay, one neural, only one neural. So only one neural. You can see this one. So this nucleus is our this one. Our processing unit, or sometimes we call it nodes. Okay, nodes, processing units. Processing unit, okay, sometimes we call the neuron. Okay, this one the nucleus. So we have the dendrite. Okay, dendrite actually is our inputs lah. Okay, this one our inputs. Okay, you can see this one. And then on the every dendrite we have the synapse. Okay, synapse here. Synapse actually is our weights. Okay, they emitted the weights here. Emitted the weights. Depend lah. Some of the input they have the weight, some of the input they don't have the weight. For example, like this lah. So this one we have the weight on this part lah. For example, so this weight, maybe this input we don't have the weight. For example, okay. For example, this is another input, so we don't have the weight. Depends lah. But for simplicity, they convert every input they put as the weight lah. Either weight is a 0 or you can put as the 1. Alright. And then they have the soma. Okay, the soma is the output here lah. Output on the neurons. Okay, output of the neuron. We call it S. And then the axon. Axon is the output lah. Okay, go to our output lah. So depends lah. So we have one input or two inputs and so on. Okay. So this one lah. How the artificial neural network comes. Okay, from this neuron. Okay, on the biological brain, they convert into the neural networks. Okay, this one so from this concept lah, the concept of biological brain, they put only one neuron. Okay, they study on the one neuron, similar like this one, and then from this one they come up with neural networks, artificial neural networks. Okay, similar like this lah. Okay, it's a simple example here. Alright, so similar like this lah that I mentioned to you. So this come from the biological brain. Okay, I think it's the biological neuron. Okay, this one only one neuron. Okay, for example, this one. So this one we call the neural networks. Okay, rangkaian neural. So that means this is one neuron, another one neuron, another one neuron, another one neuron. okay, combined with another one neuron, this one we call the neural network lah. Okay, but if you focus only one here, so we call the neuron, okay, or neural, but when we combine more than one, okay, more than one neuron, so that's why we call the networks, okay, the neural networks. Okay, for example, that I mentioned to you, normally this is we call the input layer. Okay, the first layer is this one, we call the input layer, and then this is output layer. Okay, output layer. And then at the middle is the hidden layer. Hidden layer. Okay, so hidden layer can be 1, can be 2, can be 3, can be 4, and up to you. Okay, this one depends on us. Okay, how many hidden layer you want to set. Okay, so but the standard is we have the input layer, output layer, and also one hidden layer lah. That is the standard lah. But that mentioned to you, the hidden layer you can set lah. More than one pun okay, or you want to set as the one pun okay. So that's why the hidden layer is in the middle lah. Maybe 1, maybe 2, maybe 3, depend on our system lah. Okay, if more than 1, so maybe our neural network will be complicated lah because of involve of many neurons. Okay, many neurons. You can see, so this one, for example, we have 1, 2, 3, 4, 5. So on the input, we have 5 inputs. Okay, that means we have 5 neurons. So you can see on the output, we have 1, 2, 3, 4, 5, 6. So another one. Okay, another interconnected with another to the hidden layer. So hidden layer, you can see we can get from the input 1, also from the input 2, also from input 3, and input 4, and so on. Okay, that's why the neural network is very complicated lah. Okay, involved of the more on mathematical. But for our class, we just focus on the simple neural network lah. Maybe we focus only maybe input only 3. Okay, hidden maybe 2, output maybe 1. Something like this lah. Okay, for simplicity. For example, like this, our class will be maybe like this. Okay, sorry. Okay, will be like this. Okay, this one. Okay. Something like this lah. This is input. Okay, this is hidden layer. Okay, this is the output layer. Alright, maybe our class, maybe we simplify like this lah. Okay, so if you go like this, so our system will be complicated lah. But if you can use the MATLAB, so no need to focus on the mathematical equation lah. So this one will be done on the MATLAB lah. Okay, that's why on the MATLAB we can how many hidden layer you want to set. So maybe you can set as the 10 pun okay, as the 2, 3, up to you. Okay, this one we can set adjust on the MATLABs. Okay, for the class, normally we focus not many neurons lah. Okay, maybe that I mentioned to you, maybe the input is the 3 or 2. Okay, and then hidden layer and also the output layer maybe 1 or 2 lah. Okay, but the concept will be similar lah if we apply more than one more like this lah, for example. But I mentioned to you, on our class, maybe we reduce the complexity lah. Maybe we just focus, for example, we have 3 inputs, okay, hidden layer 2 or 3, and then the output maybe 1 or 2, okay. Alright, so this is some keywords related to neural networks. Okay, so we have the neural model, okay, learning, teaching phase, okay, activation function. Alright, so model, parameter, okay, training data, okay, input and output, error, weight, adaptation, and so on. Okay, so a lot of keywords that are related to the neural network lah. Okay. Okay, so this is some application of neural networks. Okay, so neural network are a learned system that can be applied to the many type and area of application. Basically, a neural network maps one function to another, and they can be applied to perform the following. For example, okay, pattern recognition. All right, so pattern matching. Okay, pattern classification, pattern completion, prediction, clustering, decision making, control, and so on. But the best application for neural network normally they're used for recognition. Okay, recognition. Either pattern recognition, okay, face recognition, okay, face recognition, pattern recognition, and so on lah. More on recognition lah. Or sometimes we use the prediction, okay, or forecasting lah. They use the forecasting. Okay, this is the because of the involve of high accuracy. Okay, high accuracy. All right, high accuracy. That's why they use the, if you want to make your system is more accuracy, you can use the neural networks. Okay, if you want to fast decision making, okay, to do the decision making, you cannot use the neural network, because the neural network we have step. Okay, we have the phase. Okay, we have, for example, for neural network we have two phase. First you have to train, that means on the training phase or on the teaching phase. Okay, and then next we can apply that means we can call as the recall phase. Okay, recall phase is more application lah. Okay, first we have to train our networks. That's why if our system want to make a decision making, the faster decision making, you cannot use, I think you cannot use the neural network lah, because of the one disadvantage of neural network will be take times. Okay, because of, I mentioned to you, so if our system if more than one input, so we have a lot of hidden layer. For example, we have 3 hidden layer. Okay, for example, and also output we have. So this one will be take time. First step we have to train. Okay, we have to train our network. This one our network lah. Okay, similar like before this. I draw like this. Okay, so we connect each other. Okay, something like this. Okay, so we have to train this one. We have to train our networks until we get the best accuracy. Okay, the best accuracy, or sometimes we call the error is equals to 0. Okay, or sometimes we can call as the minimized error. Depends on the amount of data. If we have a lot of data, okay, we have more than 20,000 data, 1,000 data, so it's quite tough to get the error is 0 lah. So that's why we can call as the minimized error. Okay, this why the error is minimized. That means almost to 0. Okay, almost to 0. That means the accuracy will be higher, or almost to 100% accuracy. For example, like that I mentioned to you before this, the first class. So maybe on the, for example, for the neural network is the like cash deposit. So how the machine want to detect the money lah. For example, for $50, $100, $10, and so on. Okay, they have to do the correct decision. Okay. So if wrong, for example, if after apply and then they got the error, so automatically will be your money will be returned lah. That the system also then can use for on the cash deposit as some example lah. Some example of the neural network. Okay. Okay, so this is some example of area of application of neural network. Okay, perhaps larger is engineering lah. Okay, memang engineering is more, we use the neural network. And then also we can apply to the electrical, mechanical, civil, robotic, and so on. Okay, you can see also we can apply to the bank, finance. Okay, also on the transportations. Okay, scheduling of the transport. Okay, medicine. Okay, on the medicine we can see the ECG monitoring. Okay, blood classification, and so on. Okay, there is a lot of application. A lot of application on the neural networks. Alright, so this is some example. I think this is I already showed this slide on the first class. Okay, you can see this one, the advantage of neural network. So when we introduce the 5% noise, okay, the human accuracy is, we have the plus minus, okay, error maybe 2%. Alright, but if you use the neural networks, okay, this one they use the simple neural network. The P is the proportional perceptron, sorry. Perceptron neural network lah. I think this is a simple on the simple neural network, but the accuracy is the 100%. When we introduce, okay, more noise, okay, for example, like 50% noise, all right, so the human accuracy will be reduced 31.6%. But for the perceptron neural network, the accuracy is okay lah, but it's okay, 59. But nowadays they can use another technique lah. This one is on the simple neural network. This is a previous, I think the all technique on the neural network lah. We call the perceptron. Okay, so now we have a lot of technique to improve this one, to improve the accuracy that I mentioned to you. Okay, so for neural network, so you want the accuracy is 100% accuracy. Okay, and also the error is 0. That is the performance of our neural network. Okay, our performance indicator for neural network is this one: 100% accuracy, error 0. Okay, that is performance of neural network. You have to remember lah. Okay, but if you have a lot of data, it's quite possible lah. It's quite possible to get 100%. Maybe you can get 99.9% is okay. 99.9 is okay. That means the error will be 0.01, for example. Okay, that is still we can accept lah. Okay, if we have a lot of data, 1,000 data, okay, 1,000 data, million of data, so that's why it's quite possible to get the 100% accuracy lah. But if we have a small data, for example, like 100 data, 200 data, 300 data, maybe we can say we can get the 100 accuracy. That means the error we can minimize to the 0 lah. Okay, the performance, you have to remember the performance of our neural network will be 100% accuracy. Okay, error 0. Okay, that is the indicator for our neural network lah. Okay. Okay, see some example lah. Okay, I think you know this one. What is the number of this one? Okay, I think already explained on already give the answer for this one for this number. Okay, so this one I will just not explain, just brief quickly. For this one, it's just a simple example of the neural networks. Okay, you can see this one. So we have the face recognition. Okay, we have this one handwriting recognition or pattern recognition. We have the plate number recognition. Okay, also apply to the medical and also on the remote sensing. Okay, on the remote sensing lah. For example, these some application some example application of the neural networks. Okay, and this one some example some examples. Okay, for handwriting recognition they use the multi-layer perceptron. For example, they use the multi-layer perceptron, one of the technique in the neural networks, okay, to research in the handwriting recognition. And also this one is the type of the handwriting recognition. They have the online and offline, okay, recognition. So this one just you can skip this one. It's just a application of the neural networks. And also this one, okay, this one is the comparison handwriting recognition, okay, versus other interface. You can see we have the keyboard, okay, speech recognition, we have the character recognition, and also we have the handwriting recognition. So they have the advantages and disadvantages lah. You can see this one. So if you use the handwriting recognition, you can see this one. The drawback is the accuracy lah. Okay, because no learning required. Okay, for our neural network, we have to train our networks. Okay, train our network until we can get the 100% accuracy. Okay, so this is some example, another example, okay, of the application of the neural networks. For example, like PDA, tablets, okay, as phone, e-pen, and so on. Okay, and then this one is the from kalam, okay, from Al-Quran to the digital pen. Okay, some example lah. Application, okay, this is also application some example of application of neural networks. So this one I just skip. Okay, this one similar like this before this. Okay, so how the system recognize the handwriting recognition. For example, this is like my okay, maybe if human also you can read this one maybe not complicated. Alright, so that's why how the system detect the recognition, this handwriting recognition. Alright, for example, like this one, okay, we have a lot of handwriting recognition. So how our system to detect the handwriting recognition. Okay, this some example. Okay, from handwriting recognition, they convert into the digital one. Okay, this one, for example, like my example, I draw, okay, I use my e-pen, okay, my e-pen, all right, okay, so and then I convert into digital, all right, so this is one of the application on neural network. So how my e-pen to detect the word that I wrote, and then also this one from the flowchart also we can convert into the digital Okay, so this is some example of neural networks. Okay, this one I already show on the first class, the comparison, not comparison, the relationship between the machine vision and the neural networks. Okay, you can see this one. So on this part, we have the camera here. Okay, for example, we have the camera here. Okay, so this is our wood, and then we put wood here. So automatically, so the image, okay, from vision will be take like this lah. Okay, for example, like this, and then on the image processing, they use the, I'm not sure. So this one we have a lot of technique lah in the machine vision. So maybe they use the on the gray codes, on the RGB code, okay, a lot of techniques. So they convert into the mathematical lah, into the mathematical data, okay, for this word. For example, this one we have 10 data, okay, 10 inputs, okay, and then from this they convert into the mathematical, okay. But us, we just use this mathematical equation to train our network here, okay. And then the first step that I mentioned to you on the neural network, we have to train, okay, or we have to learn, okay. That's why we have to train our network until we can get the error almost 100% lah, 100%, and the error will be 0 lah, okay. So this is our indicator performance for our training, okay. If you get this one, all right, so we can apply lah, all right, we can apply. For example, after we train, okay, for example, this data, okay, we have a lot of data, so this data represent for this wood, okay, bitango, or this wood, durian, okay, another wood, okay, for example. And then after we train, and then we get the 100% accuracy, then we can take any example of wood, and then automatically our network will be give the result. For example, if this is wood for nyato, all right, or ramen, okay, for example, right, that is the function on the neural network, okay. So they use the this one image, okay, image, and then from image they convert into the mathematical data. So on the mathematical data, we go for our neural networks. We train our neural networks until our neural network we get the almost 100% accuracy and also minimize error. Then we can apply lah, okay, and then we can apply any wood here. Okay, we put any wood here. So automatically the result will be indicator lah, the ramen, nyato, durian, and so on. Okay. Right. So this is a general ANN can be categorized by, okay, first is the model. Okay, you can see. So on the neural network we have a lot of model lah. Okay, we have the simple we call simple neural networks. Okay, on the simple neural network we have the Markov. Okay, I will explain next week. Okay, we have herbs, for example. We have the Adeline, okay, Madeline, and we have Fukushima, for example. Okay, this inside the simple neural networks. And then another one is the backpropagation. Okay, so this is the model. The first categorized by model. Okay, what model you want to use? Okay, on the model, its pattern is of connection between the neurons. Okay, also called its architecture of the model lah. And then the artificial function. Okay, artificial function of used in the neuron. Okay, this one. So this one only one neuron. Okay, this one we have for example 3 neuron input, hidden layer, and also the output lah. And then we have the learning algorithm lah. Okay, so learning on the first step we have to train our network lah. So we have to learn algorithm lah in this one. That means on the learning we have to adapt our weight lah. For example, this is with input 1. On input 1 we have the weight 1 lah. So this weight will be adapt until we can get the best weight lah. Okay. So which the method is determine its weight lah. So the learning algorithm will be determine the weight lah. How the weight is adapt. Okay, for every iteration lah. Okay, so neural network can be categorized into 3 model. You can see this one. We have the feed forwards. Okay, feed forwards. All signal flow in one direction lah. Okay, that I mentioned to you. So we have the input, hidden layer, and output. Okay, for example, we have like this. Okay. So straightforward from input to the output. Okay. That's we call the feed forward. Okay, this one feed forward lah. Okay, this one we call the feed forwards. And then if feedback, we have the feedback lah. Okay, feedback to itself. Okay, input to output to output, or outputs to header layer, or outputs to input layer. Alright, so this one we call the feedbacks. Okay, the feedback. That means the signal from the neuron in upper layer or the input layer, output layer are feedback either its own or to the neuron in the lower layer lah. That means on the header layer or to the input layer. Okay, so another one is the sesula lah. Sesula is the connected in the sesula manner like our phone lah. It's a random. It's the random. Okay, so this is some example. Normally we use these two techniques lah. Okay, to categorize. So we use the feed forward or we use the feedbacks. Okay, sometimes we call the recurrent. Okay, recurrent networks. The feedback sometimes we call the recurrent. Another name for the neural network lah, for feedback. Okay, we call the recurrent networks. Okay, so recurrent we have the feedback lah. Okay, to it owns or to this one lah. For example, we have to feedback to the inputs. Okay, there's a difference between the feed forward and feedback lah, or recurrent networks. Okay, so this is the neural network involves two phases that I mentioned to you. Okay, so we have two phases on the neural network. First is learning phase or training phase. Okay, second we have the recall phase or application phase lah. Alright, so that's why the neural network will be take time. Okay, will be take time because we have first we have to train our networks. Okay, we have to train our network on the learning phase. We have to train networks until we satisfy the result. That means that I mentioned to you, the indicator for performance is the 100% accuracy and error is 0. Okay, then we can use for application lah. Okay, to solve the task. Okay, that's why you can see this one. So on learning phase, usually train until it learn it task lah. That means until we get this one lah. Until our network will be higher accuracy and less error. Okay, and then after we satisfy the training phase, and then we can go for recall phase lah. Recall phase is the application lah. That means we can use this neural network to solve the task. Okay, so that I mentioned to you. So on the neural network we have two phase, learning phase and recall phase lah. So learning phase will be adapt the weight. That means we be train our networks until we get the error is almost 0, and then the accuracy is almost 100% lah. Okay, so that is our performance of neural networks. Okay, so you can see this one that I mentioned to you. Alright, so AN solve a task when its weights are added through the learning phase. On the dimension to you, on learning phase, the weight will be added lah. The weight will be added depends on the iteration lah. That means we have 8 iteration. Every iteration we have to add the weights. Okay, and then the neural network has been trained. Okay, you have to remember. That's why we have to train first before they can be used. Okay, that's why we will take time. If you design the neural network, first you have to train. We cannot straightforward apply to our system. So cannot, because of you apply to our system. So maybe we got the not good result. Result is not so good lah. So that's why we have to train. The first step, we have to train our networks until we satisfy the output. Then we can go for the recall lah. That means we can solve the task. Okay, so you can see this one. The given training pattern, okay, and their weight are adjusted iteratively until the error function is minimized. I mentioned to you. So error minimized is almost 0 lah. If it's the best is error is 0 lah. But if your data, okay, data is too many data, okay, 1,000 data, million data, is quite possible to get the error is 0. So that's why we can just minimize the error lah. Okay, almost to 0 lah. Okay, once the neural networks have been trained, no more training is needed lah. That means only one train. Okay, this one, only one train. Just we train our network and then we satisfy this one. Okay, no need to train again. Okay, we just can go for the next phase, is the application phase. But if you're not satisfied this one, maybe you can check on your data or you can train again. Okay, if your output is not so good, okay, the performance of the error is not minimized, okay, maybe we can check on data is correct, okay, or our training is correct, okay. If not, so we have to try again until we satisfy the output on the training pattern, on the training phase. Okay, so on the learning, we have two types of learning. So first is the supervised learning. Okay, so on the supervised learning, we give the learning by teacher. Okay, learning with teacher, signal or target lah. Normally we use the target. Okay, for our system, normally we use the target lah. So for example, we have 5 data. Okay, this one we have x1. Okay, for example lah, x1, x2, x3, x4, and so on. We have, for example, we have 4 data lah. We have a lot of data here, Okay, so for example, if we have a lot of data, maybe we can get another one target. We call the xt lah, for example, x target. So this one we can get from this average. Okay, from this one calculate and then get the average. So this one is our target lah. That means our training is supervised learning lah. That means we give the target. Okay, we give the signal lah, teacher signal. Okay, teacher signal or target lah. That's we call the supervised. If another one is the unsupervised, that means learning without use the target lah or use the teacher signal lah. So this one will be use the mathematical cost function lah. They will use the cost function. This one will be select the winner lah. Select the winner. Okay, so we go for supervised learning. Okay, supervised learning. Right. So in the supervised learning, the training pattern are provided to the neural network together with teaching signal or target lah. So that I mentioned to you. So normally we give a target or teaching signal lah. Okay. The difference between the neural network output and target is we call the error. Okay. For example, output we can call as the Y, and then the target is called the E. So that is the error lah. For example, is we call the X lah. X. So our error is X minus Y. The difference between the outputs and the target is we call the error lah, error signal. Okay, so initially the output of neural network will give a large error during the learning phase. It's normal. It's a normal. So because the first step our network is not so good, so that's why we have to provide the learning phase until our network is get the best performance. Then we can go for the next stage lah, is the recall phase for solve the task. Okay, and then the error then minimized through the continuous adaptation of the weight to solve the problem through the learning algorithms. Okay, and then every iteration, so we minimize the error lah, minimize the error through the continuous adaptation of the weight lah. So that's I mentioned to you. So we have, this is one neuron one neuron x1, x2, x3, and then this weight 1, weight 2, weight 3. Okay, so every iteration, for example, we have 8 iterations. So first iteration, this one will be adapt, weight 2 will be adapt, weight 3 will be adapt, and then until iteration 8, so the weight will be adapt lah. Okay, depends lah, adapt or not, depends on the learning model that you use lah. Okay, so this is some example lah. Some example they use the learning configuration So at the end when the error becomes small, okay, the neural network is assumed have learned the tasks and the training is stopped lah. Okay, normally when we stop the training, normally error is minimized lah. Error is minimized, and then the error, then you can stop the training lah. For example, you can set the like 1000 iteration, okay, or you can set as the 1000 epoch, okay, epoch. We can set as the 1000 epoch, okay, 1000 lah, for example. If okay, this epoch, okay, until hundreds, okay, then your networks will be minimize error, then you automatically can stop, okay, automatically then stop. No need to go for until 1000, okay, only hundreds, but we certified the error here, so automatically we can stop lah, because our network is already good because of the minimized error. Okay, that is the epoch lah, for example. So for example, on the every epoch we have 8 iterations, so we'll be repeat lah. Okay, we'll be repeat. For example, one epoch we have 8 iterations. So 1000, that means will be repeat again until 8 iteration multiplied by 1000 approach. Okay, maybe until 100, so error is 0. So then automatically, if you use the MATLAB, so automatically will be stopped lah. The training will be stopped. Okay, will be stopped, and then you can apply your neural network to solve the task. Okay, and for unsupervised learning, they use the, I mentioned to you, they use the mathematical equation. They use the auxiliary cost function. Okay, this one, they select the, from this formula, they select the winner lah. Okay, select the winner. But for our class, normally we use the supervised, we give the target lah. For simplicity, okay, so normally we just create the target lah. We create the target. This means we create from, maybe from average, okay. Okay, depends maybe we can create another month. For example, for forecasting, we can take another month as our target. For example, that is how we create the supervised, or we create the target. Okay, this is unsupervised. That means from this one they use the auxiliary cost function, and then they get this one similar like our input. So this is the winner lah. Okay, that's why this is very complicated lah if we use the unsupervised learning. So on my class, normally we use the supervised lah. Supervised, that means we give the target. Okay, next is the neural network paradigm and classifications. Okay, so there is number of neural network paradigm developed over the past few decades. Right, so this paradigm are mainly used through their different learning algorithm rather than their models. Alright, so some of the neural network paradigm are named after their proposer such as Hopfield, Cohonen, that I mentioned to you, McCullough, okay, McCullough, Herbst, okay, that is come from the proposer come the founder, okay. Okay, so this is some classification on the techniques that I mentioned to you, technique inside the neural networks. All right. So we have, for example, like neural network model. Okay, that's why you can see we have a lot of model here. Okay, this one also cover in the neural network. So we have a lot of technique inside we have a lot of model neural network model inside our neural network. But in our class, we just focus only the simple network and the backpropagation. Okay, you can see we have the supervised. Okay, this one will be covered on the class. Okay, we have the backpropagation. So we use the supervised. Okay, supervised. And also we have the technique using the unsupervised. So for example, like SOM, okay, SOM, self organizing maps, okay, and then also the feedback, recurrent propagation, and so on. Okay, this is some neural network classification. Okay, so this is performance that I mentioned to you. All right, you can see this one. 100% performance, error is 0. That is the indicator, okay, or KPI for neural network lah. Okay, the performance of, to measure the performance of neural network is the best is accuracy is 100%, error is 0. That is the best lah, the best. But I mentioned to you before this, if we have a lot of data, it's quite tough or possible to get the 0 lah. That's why we can almost 0 is okay. That means the minimized error lah, minimized error, and then our accuracy will be increased lah. That's why we call here is a 100% performance. Okay, that is the indicator for good performance of the neural networks. Okay, for example, this one. So how to detect this one? For example, cow. So automatically, so after we train our networks, and then we can apply. So automatically, when we try apply this one, okay, so this animal, okay, our network will be detect the correct. So that's we call a performance of our neural networks. Okay. Okay, so this is some important parameter that you have to know. All right. We have the first network topology. Network topology is that I mentioned to you. Maybe we have the feed forwards. Okay, feed forward. Okay, we have feedback. Okay, and then we have the number of layer in the networks. That means input layer. Okay, input layer we have how many neurons. Okay, okay, that is on the neuron layer. Okay, on the hidden layer how many neurons. Okay, and then on the output layer how many neurons, on how many layer. On the, for example, like this is standard, we have input, hidden, and output. Okay, maybe you can set how many layer on the hidden, okay, on this one and then how many neuron, okay, depends on this one okay, the input, how many neurons we have, 3 neuron for input, for example, and then the calculation per iteration, okay, iteration, so how many iteration we have, for example, if we have 2 similar like this, 0 0 0 1 1 0 1 1, this one we call the iteration, iteration 1, iteration 2, iteration 3, iteration 4. For example, this is input 1, input 2. Okay. For example, if 3, okay, so 0 0 0 0 0 1, like similar like digital similar like digital So this is, for example, like input okay. For example, we call the iteration So this one we have 4 iteration. Okay, this one after complete 4 iteration we call 1 epoch. Okay, 1 epoch. Complete 1 iteration. For example, we set our epoch 10. That means after complete 1 epoch will be repeat until 10 times. That we call the 10 epoch, for example. This one we call the 1 epoch. Okay. Complete 4 iteration, 1 epoch. Okay. If we have 8 iteration, after complete 8 iteration, that we call the 1 epoch And then the speed to recall the pattern. Okay, this one depends on the performance of your laptops. Okay, network performance. Okay, network plasticity and network capacity and so on. Okay, this is some parameter that you have to know. Okay, and then another parameter that you have to know is the degree of adaptation of the neural networks. Okay, the bias. Actually, on the neural network we have some bias This one, for example, that we have this is our X input 1, input 2. Okay, some of the networks we have the bias. Okay, so this one, the function of bias will be covered on the next week Okay, so the bias here, the function is to convert, okay, to convert our input And then we have another one is the threshold. Okay, and then the boundary of the weight. Okay, initial value of the weight. Normally, if for MATLAB, we can set what is the initial weight For simplicity, we can set as the weight is the 0 For simplicity, automatically weight 3, for example, weight 1, weight 2 set as the 0 That's why you can set initial value, what is the initial value of the weight. Okay, and then the choice of non-linearity function and activation function. Okay, network noise immunity and steady state or final value of the synapse weights Okay, so this is a preliminary investigation. Right, so this one, maybe you can read this one. Okay, first is you need to identify the task. Okay, you have to know You have to know what the task you want to solve. Okay, and then what suitable model, neural network model for this application. Okay, you want to solve the task. Okay, what is the application, the suitable neural network model, and then you have to set Okay, which neural network paradigm suitable for your application, okay, and so on. Okay, so this is a important aspect when implementing neural networks. Okay, which models, okay, single layer or multi-layer, how many inputs, how many header layer, how many output layer, okay, which learning rules to be used, and what kind of activation function is the neuron. Okay, so there is some aspect that we have to know when we implementing the neural network Okay, so and then also we said as this is supervised or unsupervised. That means if supervised, okay, there is available for training pattern. Okay, and also you can see there is enough. Okay, and then you can see this one. Wrong training pattern will be yield wrong result Okay, that's why you have to make sure your target or your training pattern is correct. Okay, because if wrong training pattern, that means your result will be wrong And then the correction selection is very important. Okay, so this is, you can see, initial initialization procedure needed before training is to start. Okay, first choose correct number of iteration. Okay, stopping criteria that I mentioned to you. So for example, if we have 4, and then how many epoch? Okay, if we have 10 epoch, that means after 10 iteration, 4 iteration, and then will be repeat until 10 times. Okay, learning parameter, momentum parameter, randomize the weight correctly. Okay, this one normally for simplicity we can set weight 1 until weight n equals to 0 for simplicity. Right? If not given, set as the 0. Okay, and then minimum error minimum error. normally we can set error is 0 lah, error is 0. But if your data too many, so maybe you can set as the 0.001 as your stopping criteria lah. Okay, and then we'll be start iteration giving the pattern one by one, and then we'll be stop learning when error minimize lah, minimize, or otherwise you can train again until if you're satisfied, then you can save the training lah, and then we can apply to the recall. Okay, recall is the application lah, we can solve the task. Okay, so this is some advantages of neural network. You can see this one, okay, more like a real nervous system. Okay, it's the based on the biological brain. All right, so this is similar, almost similar like real nervous system. Okay, solving problems that are too complex. Okay, and quickly and relatively easily model. Okay, provide analytical alternative to conventional technique, which are often limited by strict assumption of the normalities, linearities, and variable independence. Okay, this is some advantages of the neural network lah. Okay, the disadvantages is first is the time consuming lah, time consuming, and actually is complicated if more than lot of data lah applied to our system lah. That is some disadvantages lah. I think mostly more on the time. Okay, for example, if you want to, your application is need to fast decision making, so I think my suggestion not use neural network lah, because the network will be, we have the train our network. Okay, if a lot of data, so we take time, maybe 1 day to train our network, maybe 2 days, depends on the system lah, depends on the performance of your laptop. Okay, performance of your data. Okay, how many data you have. Okay. So that's why will be take time for the neural networks. Okay, this is some example lah. Some example that I mentioned to you. The application of the neural network is the currency recognition and so on. Okay, so this one is the some example. I think this one I already show on the first class. Okay, relationship between the image processing. Okay, on and the AI. Okay, on the AI part we just focus this one lah. Okay, on the neural network. Okay, from the features iteration. Okay, this features iteration from image, they are convert into the mathematical. Okay, on the mathematical data lah. Okay, on the mathematical data. So on the mathematical data we use on the neural network to train our network, and then after train, then we certify the result. We can apply to recognize the currency of our, or recognize the amount of our money here. Okay. Okay, so this is some technology involved. Okay, for the neural network, we have the sensor. Okay, for example, like vision sensor. Okay, mission is the like our camera. Okay, we have the servo motor. Okay, DSP. Okay, image processing. Okay, this one will be on the mission. Okay, feature selection. Okay, this one is our part lah, neural networks. Okay, electronic software, machine design lah. Okay, so this is some example of prototype lah. Prototype for currency recognition or the similar like cash deposit lah, to detect how many what is the amount of our money. For example, $10, $20, $50, $100, and so on. Okay, similar like this one lah. This some application some application on the neural networks. Okay, this is a prototype currency recognition machine by neural network. Okay, this is first prototype. Okay, for currency recognition. All right, so next we go for the historical perspective of neural networks. Okay, so this one some important names on the neural network research. Okay, that I mentioned to you. So this is on will be covered on the simple neural network lah. Simple neural network. The first we have the McCullough and Pitt. Okay, McCullough and Pitt on 1943 will be introduced the first neuron model lah. Okay, neuron model. This one lah. Like I mentioned to you, so this one we call the neural model, right? So this is x1, x2, x3, and then this is s, this is y. Okay, for example, this introduced by McCullough and Pitt, and then Donald Herbst in 1949 will be introduced the learning. Okay, learning how the weight here, the weight 1, weight 2, weight 3 will be adapts. How the weight will be adapts. This one we call the on the learning rule lah. Will be introduced by Donald Herbst. Okay, that's why we have the Herbst. Okay, the first we have the McCullough, and for the simple neural network, we have the McCullough and Pitt. Okay, this one, and then second we have the Herbst learning. Okay, and then we have the perceptron. Okay, perceptron. Another one perceptron lah. So on 1951, will be introduced the neural machine lah. This one from by Marvin Minsky lah, and then the Rosenblatt will be introduce the perceptron. Okay, on the simple neural networks. Okay, so this is why do we need to study from the historical perspective lah. Okay, so it's important to study neural network from its historical perspective, such that we would be able to know the pitfall of primitive, okay, the primitive neural networks, and also to able to study the measure, the researcher to overcome such a limitation lah, right? So through this knowledge, we would be able to discover new ideas and insight into better neuro-models, which can help us to solve more demanding application. Okay, so that's why I mentioned to you. So nowadays, more scientists go for new research, okay, or hybrids, okay, hybrid the technique. For example, hybrid from neural networks that I mentioned to you. On neural network, we have a lot of techniques. Okay, so they are hybrid with another techniques. Okay, now they focus on more than one techniques lah. Okay, that we call the hybrid technique lah. Okay, so on the neural network, we have the early years. Okay, this one you can read. I think we can skip this one. We have the early year, we have the golden year, we have the quick years. Okay. Okay, so this one I think you can read on the slide already given. Okay, we skip this one. So this is some example. They use the perceptron. Okay, so this is some example lah, perceptron. They use the neural network perceptron. Okay, this one I just skip this one. Okay, so this you can see the early years for the neural networks start from the 1940 something until 1960 something lah. Okay, from McCullough and Pitt until the Minsky and Pepper lah. Alright. And then also we have the quiet years. Okay, this one, okay, will be quiet years. So this one, the quiet years will be on 1970s and 90s. This one will be focused on the digital lah. This one focus on digitals, and also on 1917 they are focused on the fuzzy logics. Okay, fuzzy logics. That's why the research on the network will be quite silent lah on this year lah. And then we have the golden years after introduce the fuzzy logic, and then we the researcher try to study, okay, more techniques other than fuzzy. So there a lot of technique found here lah. That's why we call the golden years. Okay. Now that I mentioned to you, now mostly the researcher focus on more than hybrid lah, more than one techniques. Okay, they focus on the combination of the 2 or 3 techniques, okay, to solve the problem lah. Okay, right. So that's all for neural networks. Okay, until for this one, until the golden years. Okay, so that's all for theoretical. So next week we will start on the simple neural network. So more calculation lah. Okay, this one is just a theoretical. Theoretical. So what is the neural networks? Okay, the application, the parameter, important parameter. So what is the learning? Okay, learning algorithms. Okay, the phase. Okay, the phase for the neural networks that I mentioned to you. We have 2 phase. Okay, we have the learning phase and we have the recall phase. Okay. So the parameter, and then the categories. Okay, the topologies. We have the feedback, feed forward, and so on. Okay, that's all for today. Is for the fundamental of the neural networks. Okay, so next week we will start on the simple neural networks. Alright, so if no question, I will stop here. Alright, so we will see you on next week lah. So next week we will start on the simple neural network lah. So simple neural network, we go for the mathematical. Okay, so this today is just more on the fundamental lah. Fundamental is the theoretical on the neural networks. Okay, all right. So that's all for today. Right? Any question? If no question, I will stop here, and then we will see you next week. Okay. All right. Thank you very much. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Okay, Doctor. Thank you.